So last semester, number 8 was probably the most missed question on this entire exam. There were a couple of reasons for that. I think first off, secant is just a harder function for students to work with because it ends up with that secant of x, tan of x. So a lot of students didn't recognize that they needed to include that chainy piece, that interior function, in both the secant and the tan. And then also there's that, we'll talk about it. So let's just take our derivative of this thing. So we recognize first that we have two terms. So we're going to use that sum property of integrals. We're going to go ahead and take the derivative of each of these separately. By the way, works the same for integrals, but whatever. We're going to take the derivative of each of these two terms separately. So the first term, that secant, we need to recognize that we have a composition of functions. This is not just secant of x, this is secant of a function of x. So, as I was saying, our dy dx, for that first term, we're going to have secant of the entire inside function times tangent of the entire inside function, because the derivative of secant is secant tangent, right? And then we need times the derivative of our inside function. So I think this broke a lot of students right off the bat. Just this idea that we needed to keep that inside function the same in both of these pieces because they're both the derivative. Like this is all the derivative. So I think that was a challenge for students. The second challenge came from taking the derivative of our 5x cubed plus pi squared. A common thing that students want to do, I never put the derivative symbol, I never put that prime, is to recognize that pi squared is just an ugly constant, right? So if we're going to finish taking the derivative of this, here I'm going to rewrite everything. I'll bring over the rest, the second term in a second. Bear with me. But if we're taking the derivative of 5x cubed times plus pi squared, this is just going to end up being 15x squared. This whole derivative here. Because the pi squared is a constant, so we just need to deal with the power rule of the one thing that has an x in it. If there is no x, she a constant. Unless we're dealing with implicit and we have a function of some other variable, whatever. But typically, constant, we can ignore it. We know pi. It's 3.14. Who cares what 3.14 is squared? All right, so now let's deal with that second term. Second term is a product rule. So let's do the derivative of the first times the second plus the first times the derivative of the second. Right, if we want to be cute about this, there's my first, and times the derivative of times my second, and its derivative. Right, I'm not going to do that one in stages because I think we're good. I'll go ahead, x squared divided by x is just an x, and then nothing cute happens with this other one. I might prefer to have the 2x out in front of the ln of x so it's clear that the argument of that natural log is just x. All right, so that's it. I mean, I could move the 15x squared out in front, but this is pretty much as cute as this derivative is going to get. This is it. Whoop. Done.